Let's jump right in. Welcome to this explainer, where we're going to unpack a super clear, actionable roadmap to take you from absolute beginner to a job-ready data scientist by 2026. We're focusing specifically on the Python ecosystem here, mixing foundational concepts with hands-on beginner projects. So if you've been feeling totally overwhelmed about where to even begin, don't worry, we're going to figure this whole thing out together.
Seriously, if you've ever Googled how to start data science from scratch and ended up just completely paralyzed by the hundreds of tools, frameworks, and courses out there, it turns out you are absolutely not alone. Everyone asks, do I learn R or Python? Should I jump right into machine learning or just start with basic data analysis? Well, today we're cutting through all that noise. We're exploring a strict, step-by-step blueprint that cuts out the fluff and just gives you a crystal clear path forward.
And you know what's really crazy about this timeline? With just 1 to 2 hours of focused daily practice, you can realistically conquer this entire field in under a year. No, you really don't need a 4-year degree to make this happen. If you're consistent, structured, and you focus on the exact right tools, 12 months is literally all it takes to build a portfolio that will totally catch a recruiter's eye. Okay, so here's our blueprint for today. We'll hit 1, the data science roadmap. 2, math and stats fundamentals. 3, Python and data analysis. 4, machine learning basics. 5, the project lifecycle. And finally, 6, building your beginner portfolio.
All right, let's dive into part 1, the data science roadmap. We need a bird's eye view of your journey.
Think of this like a giant puzzle, where every single phase builds directly on the last one. You'll start out in months 1 and 2 mastering the core logic of math and statistics. Then you'll spend months 2 through 5 really getting into Python, data analysis, and SQL. By month 5, boom, you're ready to tackle machine learning. And finally, you transition away from theory into real-world deployment by building actual projects, which gets you job-ready by the end of the year. The biggest thing to remember here, do not rush this process. Every block is the foundation for the next one.
Which brings us to part 2, math and stats fundamentals. This is all about laying that logical foundation.
Look, before you even touch a line of code, you have to understand the math that powers all this. And the crucial starting point is descriptive statistics. These act as the broad strokes that literally help you find the stories hidden inside raw numbers. Like if you have a massive, chaotic spreadsheet of customer ages, simply finding the average, or the mean, is a descriptive statistic. It's the absolute backbone of data science because it lets you take millions of messy data points and describe them so a human being can actually make sense of them. Now, beyond those descriptive stats, there are a few other mathematical pillars you've got to know. You'll need a solid grasp of probability so you can understand distributions. You need a little bit of linear algebra, mostly because vectors and matrices are how computers actually process data under the hood. And you absolutely have to understand hypothesis testing. Look, you don't need to be a math genius, I promise, but grasping concepts like p-values ensures your findings aren't just a total fluke. You have to be able to prove your insights are statistically significant. All right, moving on to part 3, Python and data analysis. Time to build the framework. Before you can write your Python scripts, you need a place to actually work, right? Well, that's where Jupyter Notebooks come in. Think of this as your primary digital workshop. It lets you easily write code, run it line by line, and visualize your messy, real-world data right next to your text explanations, all in one single place. Actually, a pro tip here, just install Anaconda to get this set up. It comes preloaded with pretty much everything a beginner needs. Once your workshop is set up, focus strictly on these core Python libraries. Don't learn a dozen tools, just these. First up is Pandas, which, fun fact, is actually named after panel data, not the bear. It is your absolute best friend for data manipulation and cleaning, also known as data wrangling. Then you have NumPy, which you'll use for heavy numerical computing and handling arrays. And finally, Matplotlib, or Seaborn, which are your go-to tools for generating really beautiful charts and visualizations. Seriously, mastering just these specific libraries will let you handle 80% of beginner data tasks. So your data is clean. That leads us to part 4, machine learning basics. It's time to install the predictive systems. When you step into the world of machine learning, it is incredibly important to understand the fundamental difference between the two main approaches. Supervised learning is what you use when you already know what you're looking for, like predicting a house price using regression or categorizing an email as spam or not spam. Unsupervised learning, on the other hand, is kind of like sending an algorithm into a pitch black room to find hidden patterns in data that doesn't have any labels. Usually, this means using clustering to group similar items together. Knowing exactly which approach to use is critical when you're trying to solve real business problems. And when it's time to actually build these predictive models in your Jupyter Notebook, Scikit-learn is going to be your absolute go-to tool. It's universally used across the industry because it totally streamlines the process of training models and testing them for accuracy. Basically, it makes sure you aren't overfitting or underfitting your data. All right, part 5, the project lifecycle. Let's talk about how the professionals actually work. To bring this all together, we really need to look at the CRISP-DM framework. This was originally published way back in 1999. It stands for Cross-Industry Standard Process for Data Mining, and what's brilliant about it is that it proves data science isn't just a straight line. It's actually a continuous, iterative loop. Notice how this cycle always starts with understanding the business problem first. Too many beginners just want to jump straight into the modeling part. But the pros, they start by asking, wait, what problem are we actually trying to solve here? Only after defining that business value do you move into preparing the data, creating a minimal viable model, and finally, deployment and evaluation. And hey, if the model doesn't actually solve the business problem, you loop right back to square one. Now, throughout this entire life cycle, evaluating your model for algorithmic bias is a standard, absolutely crucial technical requirement. Bias happens when unintended skews in your training data get accidentally built directly into your predictive models. Since these models evaluate real-world scenarios, everything from risk assessments to operational diagnostics, checking your data for these anomalies ensures your analysis stays accurate, responsible, and privacy compliant. And finally, part 6, building your beginner portfolio. This is how we escape tutorial hell. Here is the absolute truth. A completed project proves to an employer what a piece of paper or a certificate simply cannot. It shows you actually know how to handle messy, real-world data. So if you don't know where to start, try these 3 highly recommended beginner-friendly analysis tasks. You could analyze survey data using pandas, try finding profitable app profiles to practice your data cleaning, or explore hacker news posts to get the hang of string handling. These use real, completely free data sets, and they will force you to apply absolutely everything you've learned. Your ultimate goal here? Aim for 3 to 5 strong, fully documented projects. And you have to upload them to your GitHub repository. Listen, recruiters and hiring managers are going to look at your GitHub profile way before they even glance at your resume. Treat your repository as your living, breathing digital resume. Show off your code, explain your business logic, and make sure to visualize your results clearly. So, we've covered the timeline, the math, the Python libraries, the frameworks, and the exact projects you need. The entire blueprint is right in front of you. You know, they say the best time to start was yesterday, but the second best time is right now. So I'm going to leave you with this question. Which beginner dataset are you going to download today to start building your own data science legacy? Seriously, stop watching tutorials, grab some messy data, and let's start coding.